So this is 2009 B, number what, 3? And so this is a 2-sample test. I wanted to make sure that we went through this. This is basically phantom, going all the way through the assumptions and conditions to the t-score and or the z-score, the p-value, and the conclusions. All right. So inside here, there's a couple things. First of all, you've got 2 different samples, right? A sample of 500 or 754 and a sample of 746. The fact that you see 2 different samples should ring a bell. I'm going to be doing a 2-sample test. Okay? Big no-no to do a 1-sample test when the scenario calls for 2-sample. It should, first of all, be awkward. You're going to have too many numbers to deal with. And you're like, wait a minute, why am I doing this? And sometimes I'll see people add it all up and say, oh, I'm just going to combine everything to make one different sample. And like, that doesn't make a whole lot of sense, but I'm going to do it anyway. So be careful about that. So 2 different samples, right? So you can tell that just by looking at the 2 different sample sizes you've got right there. And so let's kind of run through the assumptions and the conditions, right? And I guess just do the whole phantom bit. And so what's my HO going to be? So the null hypothesis starts off, right? You're trying to determine whether the proportion of individuals treated with CPR is different or actually is less than the proportion of people treated with the cardio pump. So, well, I'll just use CP for cardio pump and CPR for the other one, right? It's just obvious. So the proportion for the cardio pump is equal to the proportion with CPR. Questions about the null?
I have a question, but it's not about this problem.
Okay.
How many questions are on the test?
10 and 3. Same thing. All right, so, okay, if we go on and talk about the alternative, what's the alternative going to be? Let's keep in the style that I've written here. I'm using equal to. It's going to be a cardio pump is what compared to CPR?
The cardio pump is
Wait, you're trying to see if it's
greater than
this?
Yeah. I did it backwards, but
Okay, so now if you went and did yours differently than mine, like if you did it backwards, if you did CPR, it's less than CP, that's great. If you did the subtraction, where if I said here that the probability of the cardio pump or the P is minus the proportions for CPR. Okay, if you did that, then okay, so CP, the proportion of the cardio pump minus the proportion for CPR, that would be equal to 0 here. So I don't care whether you do the difference or you do it's equal to, you're going to get the same results. I'm going to go with just what we started off here, just because I don't have a whole lot of room to write. Okay? And so, here we go. If you got your null, you got your alternative. Our assumptions. Okay? The first one is randomness. How can we justify randomness? It's actually stated in the problem.
We don't have to justify it any other way than that, right?
Okay? Because there's a coin toss. Coin toss, guaranteed to be automatically, right? Well, hold on, back up. That's the randomness part comes in from, would you think that someone who's been treated with CPR versus someone else who's been treated with CPR, do you think that they would have any influence with each other?
No, but it's not
No.
independence, not randomness.
Okay?
Isn't there not having any?
No, you're right. I'm getting ahead of myself. Okay, so randomness here is stated independence. Okay, independence is, we got 2 different forms of independence, right? You got the independent groups and you got the independent individuals. So people treated with CPR or people treated with one person treated with it's not going to be affected by another person. So if I survive, if my success rate is something that's not going to influence someone else. Independent groups.
Whoa. What's the independence?
Independence is because one person that has a heart attack with CPR doesn't have any effect on the second person that had a heart attack and had CPR. They don't have any influence on each other.
Right. So if you had a heart attack and you got CPR, and then she had a heart attack and she got CPR, the result, your survival rate and her survival rate wouldn't influence each other.
Unless I scare her and she has a heart attack and then her heart attack makes
But
me
we're
have a heart
assuming
attack.
this is all random too. Okay? So that's independence by itself. Independent group says if you're treated with the heart pump, the cardio pump, and she's treated with CPR, there's no connection between those two.
So no connection between
The two different groups either. So independence holds true for both groups here and here. And I don't have a whole lot of room to write that out, but you get the idea what we said. Okay? And then you had 10%. In 10%, you've got the two groups where we had, was it 754?
Wait. Yeah, 754.
Or 7,540 and then 7,460. Right?
Yeah.
My population of people that are treated with CPR or treated with the cardio pump in the population is well over just 7,000 people. It's probably in the hundreds of thousands of people, right? So that's definitely less than 10% of my population. And then you have the success and failure for both groups. And here we have, let's see, 37 successes and a whole lot of failures. That stinks. And then the other one you had 15. I haven't calculated that. What's the, let's see. So that would be 717 and 731. So you got here all that stuff right there, all that's greater than or equal to 10. So you've got a sample size that's large enough to do this with. Okay? And so if you got all that stuff, that's my conditions. That's how they're satisfied. Okay? All of them are good to go. My null hypothesis is there. Okay, so state the conditions and indicate how they're satisfied. I didn't write it on my screen, but you get the idea from what we said earlier. Okay? So if we keep on going, what we're going to do now is talk about perform the statistical test to determine whether the survival rate for the patients treated with a cardio pump is significantly higher than that of the survival rate for the patients. Let's keep our phantom going. And so what's the test name? 2-prop Z test. Okay. Oops, I forgot one thing. PHANT. Okay. So what's our test statistic here?
Is the margin of error formula in the screen packet?
It is in the green packet, yes. So your Z-score should be equal to 3.066. Going to find my p-value, which is about 0.0011. Typically when you write a p-value out, you want to go to that fourth decimal place. That's pretty common practice. So make sure you go to those 4 places. Okay, and now your conclusion.
Okay, let's see.
So-
Are we using an alpha of 0.05?
So let's go with an alpha level. Write that down here. Alpha equal to 0.05.
Are you going to want us to write that?
It's not crucial, but it's a good practice because lots of questions on the AP test, if you read through their solutions, it's asking, did they make a reference to the alpha level? Either stated it explicitly like you wrote it down, or you implied that your p-value is less than its whatever it was. If you just get in the habit of writing it down all the time, you're good to go. Okay? So what would our conclusion be?
Okay, let's see.
Let Anybody want to guess? All right. All right, so I don't have enough room to write out there, so you're just going to have to listen. So what we would have to do is you want to make sure to talk about the p-value in relation to your alpha level, and then you're going to make sure to talk about the conclusion in context of the problem. So what you said earlier, we're going to reject our null hypothesis because my p-value of 0.011 is less than my alpha of 0.05. We have provided strong evidence to suggest that people treated with the cardio pump, the proportion of people, the survival rate, is higher than people that, the survival rate for the people treated with CPR.
Okay.
All right?
And then you stop.
And that's it.